Jai Hind, everybody. It has become very fashionable these days to talk of technologies, and especially that they are going to make transformational changes in the battlefield. With whomsoever you will talk and read large number of articles, you'll find people are talking about the AI, generative AI, machine learning, robotics, Internet of Things, and the whole list of these technologies. And there are close to 30 of them which are currently can be included in part of so-called the term niche technologies, and they are definitely changing the war fighting. But somehow we are not able to potential of these technologies in war fighting is war fighting, for which we are going to get prepared as time goes ahead. I think we could not have been more fortunate than getting Dr. Parimal Kumar, who is the scientific advisor to the CISC at headquarter IDS, to really unfold this subject for all of us as to how these technologies can actually impact the joint war fighting. So with that preamble, I will request Dr. Ulpi to introduce the speaker, and then he shall request him to.
Thank you, sir, for being here. So, Dr. Parimal Kumar currently serves as the OS and SA to CISC. He holds an MSc in Computer Science from the University of Allahabad, an MTech in Computer Science and Engineering from IIT Delhi, and MBA from IGNOU, and a PhD in Business Administration from Aligarh Muslim University. He has undertaken extensive professional training, including being a certified software and companies such as OCCS4 from IIT Pune and DRDL Hyderabad, as well as programs from ISI Kolkata, CAIR Bangalore, ESCI Hyderabad, CTAC Mohali, TIFAC New, ITM Masuri, DIPR Delhi, MDI Gurgaon, NIFM Faridabad, and the IC2 Institute at the University of Texas at Austin. Dr. Kumar is a 32 years of experience in various scientific and techno-managerial positions within DRDO, including roles at Recruitment and Assessment Center, Scientific Analysis Group, and DRDO headquarters. He has had the distinct honor of simultaneously serving as SA to CISC, SA to COAS, additional charges, SA to CNS, additional charge, and SA to CAS, additional charge, making him the only scientist to have held all four positions at once. His research has been presented at several seminars and conferences and published in various journals. In recognition of his distinguished service, he was awarded the CISC Commendation in 2022 and the Chairman DRDO Commendation on Technology Day 2024 for his dedication and professional excellence. Once again, I would thank you, sir, and the floor is all yours.
Thank you, Dr. Ulpi, for very nice introduction. Jai Hind, DG CENJOWS, officers from CENJOWS, veterans and officers attending online, research scholars and research interns, and all ladies and gentlemen who are attending this talk. First of all, let me thanks to CENJOWS for giving me this opportunity for speaking on a very relevant topic. The most important, it says Rising Relevance of Technology for Joint Warfighting. Initially, when CENJOWS approached me, they told me that you can speak on any topic. But I requested that please give me some topics so that the subject gets bounded. Because without boundary conditions, it is hard to address a problem. And when I was going through the publicly available literature, being a scientist, I also a research scholar. And when I was researching through what is publicly available so that I can add my flavor to that and initial and original thought process. So I found that this rising relevance of technology for joint war fighting, which is the topic, it is actually technology has been always relevant for joint war fighting. And that's why I have little bit added one word, ever rising, ever I have added. And we'll see when as we move across the presentation.
Yes.
Yeah. And the point is that rising relevance of technology is fine. And once we establish that how technology is relevant for joint war fighting, then the point is that what is the action after that? So that we understand, and we'll see in this talk also. So the logical next step is that how we can augment the joint war fighting capabilities through innovation and self-reliance. So when I mean innovation, I mean technological innovation. And the words innovation and self-reliance, sometimes we feel that innovation can lead to self-reliance. But in with my experiences and personal views, I understand, or that's my views, that innovation alone cannot lead to self-reliance. We have to make a considered and approach to make things self-reliance. We have to work towards it. That's why innovation and self-reliance. So that's the topic, ever-rising relevance of technology for joint war fighting, followed by how to augmenting joint war fighting capabilities through innovation and self-reliance. Next slide, please. Yeah.
This will take you right next. Okay. This will take you back.
Okay. Take it. Okay. So before I formally go through my presentation, let me introduce to my charter of duties and just one slide. And this emanates from the allocation of business rules of the Department of Defense Research and Development, Raksha Anusandhan Tatha Vikas Vibhag. And it says that role of scientific advisors is to rendering advice on all scientific aspects of weapons, weapon platforms, military operations, surveillance, support, and logistics in all likely theaters of conflict. So that's my charter of duties. And I have programmed my presentation like this: that introduction, which covers the definition of warfare, what we mean by joint warfare, though I know that this terminology is not new to this audience, but still I like to define it. Then factors affecting joint warfare and relevance of technology in joint warfare. Then technological trends in joint warfighting, as DG CENJOWS was also mentioning. But we'll see it from a perspective that what are the trends, and then to case studies, then impact, challenges, and future outlook, and how innovation and self-reliance can augment warfighting capabilities and the way forward to achieve the national goal of achieving self-reliance and augmenting the joint warfighting capabilities. So, the definition of joint warfighting. I had the privilege of attending lectures on joint warfighting by very senior military officers. I'm not taking the names. And the definition itself of joint warfighting itself is a 45 minutes or 1 hour long lecture, but I'll go by a simple definition by this, a working definition, which says that coordinated use of forces across land, air, sea, space, and cyberspace. Earlier, we used to have land, air, and sea. Now, space and cyberspace have been added to achieve strategic objectives. So, this is the definition by which we'll go by joint war fighting in this presentation. So, when we talk of it, technology, let's see that what are other factors that impact joint warfare. And The joint warfare is affected by the strategic and geopolitical context. We know that the geopolitical developments which is taking place around us and internationally, that certainly affects our the joint warfare strategies. Then technological advancements and integration. As the CENJOWS was also mentioned that the 13 areas in which we can put today the technology, which includes AI, quantum, the Internet of Things, we will see as we go through the presentation. But the key point is that when you talk of joint warfare, these technologies need to be integrated. Until unless we integrate these technologies, the joint warfare capability cannot be achieved. Then the operational complexity. Operations have become complex when you talk of joint warfare. And it is then multi-dimensional operations. It is land, air, sea, space, land, air, sea, space, and cyberspace. And how do you connect them? So multiple dimensions are there. And so the moment we go to the multiple dimensions, the operational operations become more and more complex. Then there are human factors. We know that in a joint warfare, the leadership and the strategy, these are two very, very important human factors. Technology itself, we cannot lead to a win, cannot lead us to a win in the war. So human factors are very important, and then the leadership factor is very, very important, and the strategies we formulate and how we integrate them. So human factor is very important. Then the resource constraints. Resources are in constant. As many of you have attended various procurement meetings and procurement boards and all, you would see that in every board we see that the numbers are limited. We do not have any unlimited numbers of any equipment, any weapon platform, small arms, whatever we say, even software. So resources are constrained, the budgetary constraints are there, human constraints are there, logistics constraints are there, various type of constraints are there, and everything has to be optimally utilized for a win or a win in a joint warfare. Then there are institutional and cultural barriers. When you talk of joint warfare, then all these military institutions, along with civil institutions also, they have to come together, they have to join hands. And when we say this thing, then the institutions, they have their own cultures also, and everything has to be integrated. So institutional and cultural barriers are there. Inertia is there when we talk of jointness and when we talk of utilization and things like that. Then there are ethical and legal considerations. When we talk of automation, we use of extensive use of artificial intelligence. So then the ethical considerations start coming up. When we are using the autonomous system, the actions taken by the decisions taken based on the either on the inputs from the autonomous systems or the autonomous system itself in the autonomous mode. Who will take the responsibility for that if anything goes wrong? So there are ethical issues. Then there are legal issues also. The lethal weapons which we are using, lethal autonomous weapon systems which we are using. So the laws for them are not fully developed yet. So there are legal considerations also. Then there is data-centric warfare. Data is so much. We are talking of AI and the amount of data is there, big data analytics we are using. So earlier that much data was not there, and on the basis of the data we are able to synchronize them and we are able to draw inferences. So the data-centric warfare is there, and the capability for data-centric warfare is one of the important factors that impact joint warfare. And last but not the least, the adversarial strategy. Our adversary is adopting which strategies that also impacts our strategy in turn and impacts the joint warfare decisions. So now we'll see the relevance of technology in warfare. So we have seen so many factors, how technology is more important. And before we see the impact, let's see a historical analysis. The word I used, ever rising relevance of technology. So I thought that technology has become relevant today only, or it has been relevant since ancient times. Early innovations in warfare, ancient and medieval periods. I'm not going through Ramayana and Mahabharata wars, but let me go up to the Maurya dynasty. And what I observed and studied also, that why Mauryan dynasty was so successful. One of the reasons behind this was the technological superiority. Technological superiority at that point of time was that the iron was also found in that area only. Today also, if you go to the Patliputra area and towards Jharkhand and Odisha regions, most of the iron ores are found in that area only. So so logically we find that that assumption seems to be correct. And since iron was found, and before that, the weapons used were of wood, stone, and all. Iron was first time found there. And so that was the technological superiority. That was one of the reasons of success of uh, Maurya Empire. Then in medieval periods, I was going through the war of Haldighati and war of Khanwa. That was war of Khanwa was between Rana Sanga and Babur. And the gunpowder was first time used in India by Babur, as far as the research I have done. And the since Babur had gunpowder, he was able to defeat a 4 times strong army, but in numerical strength. And strategically, if we study the Battle of one of the research scholars we can study it, strategically also Rana Sanga was in better position. He had surrounded the Babur's forces from two sides, but then he just shifted the directions of cannons, and he had gunpowder, and he was able to neutralize and win a larger army that firmly established the empire. So that was also technology of iron, technology of gunpowder. Now let's come to industrial revolution and mechanized warfare. So railroads and telegraphs. When we talk of Germany established the railroads, and telegraphs was a big innovation at that point of time. Then and with railroads, the transportation improved a lot. So the industrial revolution and mechanized warfare, there also we see that technology was very important, very relevant. Then we come to World War I. That is called chemists war also, because several types of chemical agents were discovered or invented at that point of time and were used in war. And machine gun, tanks, some part of mechanized infantry, these were used in the World War I, and with this, so we can see the relevance of technology in the World War I. Then let's come to World War II, the era of combined arms, and there this integration started happening. And Germans used one technique which is called Blitzkrieg tactics. The service officers may be knowing better than me. Blitzkrieg tactics, which means lightning war. So it is a very fast war where the air, land, and sea forces are all integrated. Mechanized infantry and supported by air power. Let's move further. So then we come to the atomic weapons or the nuclear weapons. And we know that the World War II ended with the use of nuclear weapons. So technology always played a vital role historically. Then comes to the Cold War. Digital revolution started taking place in warfare, computing and automation. Space race started, network-centric warfare started. Again, we see that technology has played a very vital role, very relevant role in the warfare. Then post-Cold War, it came to precision war. And in Gulf War in 1991, we used not we used, but the PGMs were used, precision guided munitions were used. Then revolution in military affairs, and then computing power started coming up, and then internet by that time it was there, and all kind of network warfare. So all these things started, and there again the integration started, and so this was post-Cold War, and now we come to contemporary era. Now we have multi-domain operations, integration across domains, land, space, land, air, water, cyber, and space. Cyber warfare has started, and very effectively we have seen it has been used in wars and autonomous systems. So we see that technology was always important from medieval era to the contemporary today's era, and that's why I'm using the word ever-rising relevance. So what is the key takeaway, key themes across history? If we analyze, there is a trend, and it says that as we have moved forward with time, the technologies have been that compression of space and time. From railroads to hypersonic missiles, technology has consistently reduced the time for mobilization and action while expanding operational research. Operational research and the optimal utilization of resources. Then force multiplication. Technology has worked as a force multiplier. Innovations like machine guns during World War I, PGMs during the Gulf War, significantly enhanced combat effectiveness without proportionately increasing the manpower. So it was a force multiplier. With the same manpower or even sometimes reduced manpower, we are more effective. Whoever was using that, they were more effective. Then information dominance. The ability to gather, process, and act on intelligence has been a critical factor in joint warfare since the introduction of telegraphs. We see that at telegraphs, the amount of data transfer was, the rate of data transfer was about 30 words per minute. And then by 1991, we were in Mbps, megabits per second. And today we have achieved Gbps. So, and also, if you see the during World War II, the Enigma machine by Alan Turing, so he was able to decrypt and decode the messages, which played a very vital role in winning the war by the alliances. Then adaptation is always a challenge. While technology offers immense potential, its effectiveness depends on integration with strategy, doctrine, and organizational structures. And this is, I think, the most important point here, because technology keeps moving at a fast rate, at least on the contemporary era, so technology is moving very, very fast. But adaptation simply doesn't mean that buying the equipment. The troops on the last mile, the troops who will be using it on the ground, they should be able to use it very, very effectively, and it should be fully integrated with our organizational structures. The leaders should be able to imbibe the technologies, and the strategies should be such that they are able to use the technologies effectively, and the integration with the strategy, doctrine, and organizational structures is very, very important. So, how technology more joint warfare as compared to other factors? We have seen many factors, out of which we find that technology is the most relevant factor because it is rapidly growing at a fast pace, and it is force multiplier across domains. Enhanced situational awareness. We saw that big data analytics and processing of large amount of data. When we process large amount of data, it gives us the enhanced situational awareness about our adversaries. Then multi-domain operations, we are able to integrate our operations along multiple domains, and precision and lethality has also increased by using the technologies. Then compression of space and time. Speed of action has increased very fast. Starting from now, we are talking of hypersonics. We see how much speed has increased, and there is a global reach. Now we are using hypersonic missiles than whoever participating in the war, and and ICBMs. So which has increased decision superiority, AI-driven decision making is taking place. Then data fusion, data gathered from various sensors, we are able to fuse it and utilize it for decision making. Then cost efficiency and force preservation, smaller yet more effective forces using technology. And since we are using technology and forces are not need not be always on the ground, so the casualties are also reduced. So since these are the advantages of using technology, therefore technology is more relevant factor as compared to other factors. Then cyber power is a game changer. Cyber capabilities disrupt enemy decision-making cycles by targeting their command and control systems. Cyber reconnaissance, superiority, and interdiction have become integral components of joint warfare. And offensive cyber operations can utilize adversary infrastructure before kinetic operations even begin. So this is very, very important. Then challenges with non-technological factors. We discussed several factors which have impact the joint warfare. The first one is human limitations. Human limitations, in addition to physical limitations, the limitations of the leadership to adopt the technology, the rate at which the technologies are adapted and integrated into the strategic gaps, which is that if we do not take technology as enablers, one can foresee that, or rather one can realize that how difficult it is to implement our strategies. So strategic gaps will be there if you do not use technology. Then resource contents, the requirement of large force structures and logistical support will be required as compared to technology-enabled operations that optimize resources through automation and precision tools. And that also we can see on the ground that the resource constraints will be much more if we do not use the technology. And technology is an enabler. Leadership is enhanced through decision support tools like AI-driven analytics. Strategy becomes more actionable with real-time intelligence and precision weaponry. Human elements are supported by autonomous systems that reduce cognitive overload and physical risks. It's very important when we talk, especially when we talk of man-machine teaming and all. You see that how much cognitive overload comes over a commander or a soldier. We see that data is coming from all types of sensors at very fast rates, and to process them and take decisions without using technology, it is very, very hard, and the cognitive overload is very high. So when we use technology, human elements are supported by autonomous systems that reduces cognitive overload and physical risks. So we have discussed till such time that what is joint warfare, the technologies which impact joint warfare, the historical analysis that how technology has been relevance and its importance have been ever rising, and how technology is more important than other factors. Now we'll discuss the technological trends in joint warfighting. Sir, as you have been telling DG CENJOWS that in his initial address that the technologies, 30 technology areas, I have listed only few of them which are more critical at this point of time, like quantum computing, which has not come into operations in day-to-day operations. I'm not covering here.
These are the which are matured actually.
Yes, these are. Yes, so when we are talking of joint warfighting, I'm as a scientific advisor, I'm going for what is today relevant, as in today's date, which can be used and which are very, very relevant and playing important role. So artificial intelligence, AI and robotics, definitely I will see in the subsequent slides that how they are playing a great role. Cyber warfare and cyber security, unmanned aerial vehicles, hypersonic weapons, and Internet of Military Things. Let's see in detail. AI and robotics for joint warfighting. AI-driven decision. Artificial intelligence is all pervasive now. I'm not going into the technique, generative adversarial networks or diffusion models and things like that. Rather, I'm focusing that how it will be relevant for the armed forces. And the first thing is that artificial intelligence is helping the armed forces in decision support and autonomy. And command and control is the first thing. Then we are using autonomous systems. Then robotics in combat and support roles, unmanned ground vehicles, manned, unmanned teaming. I was talking of cognitive load earlier. We see that without technology, how artificial intelligence is helping in reducing the cognitive load when we talk of manned and unmanned teaming. Then robot swarms, we have swarms of UAVs, and it is very, very effective. We have seen in the recent wars also. Then Internet of Military Things, it's very, very effective. It is helping us in integration and decision making, and not only decision making, but also taking actions remotely. Then advanced applications in warfare, AI-powered surveillance, that's already in use, counter-drone technologies, loitering munitions. Then these are the challenges and ethical considerations. One is that integration cost of integration is quite high because we need to integrate, and then technological challenges also in integration, human challenges are there, technological challenges are there, then ethical concerns are there. I was talking about the AI and autonomous systems when we are using the decisions taken either in autonomous mode by a robot or the decisions taken by a leader, military leader, based on the inputs from the AI system. If any way it goes wrong, then who will be responsible? So these are the ethical concerns. And trustworthiness also comes into play here. Then cyber security risks are there at both sides. So these are the challenges and ethical considerations. So in addition to AI, let's see on cyber warfare and cyber security protection for serial attacks on military networks. So that is cyber security we need. And as an example, this is publicly available, this information. Indian Army Commander Cyber Operations Support Wing, CCOSW, that has been established for cyber warfare and cyber security, and definitely it will help in joint warfare also. Then unmanned aerial vehicles, real-time intelligence, precision strikes, and drone swarms. The example is Turkish makes 2 UAV with AI-supported autopilot, and that there is the point. If there is an autopilot and the decisions are taken in an autonomous mode, then the legal and ethical considerations come into play. Then hypersonic weapons, rapid strike capabilities with speed exceeding Mach 5. That's the definition of hypersonic, basic definition, that is speeds more than Mach 5. And example is our DRDO HSTDV technology demonstrated vehicle. And Internet of Military Things, seamless battlefield connectivity through interconnected devices. And that will definitely play a very, or rather playing a very important role in joint war fighting. So these are the technological trends in joint war fighting. If you see the case study, Indian Army, we focus on drones, counter drones systems, secure communication devices like CENJOWS. CENJOWS is secure army mobile Bharat version. So these are already in use, and it is publicly available data. Turkey directed energy weapons like ALCA system. It is a DEW, and it has been already used, and advancement in robotics. The global trend says that integration of machine learning battle networks, and we have seen in that Russia-Ukraine conflict. So what is the impact of technology on joint war fighting? Instead of going into several different technological domains, let's see that what is the impact if we want to see the trends. So enhanced situational awareness, real-time data fusion through command control, communication, computers, intelligence, surveillance, and reconnaissance systems. So this gives us real-time, better enhanced situational awareness about the adversary. Then precision and lethality has increased, reduced collateral damages with precision guided decisions. And when we have collateral damages, then it brings legal issues also, legal and ethical issues. So that has reduced. Lethality also has increased. Then asymmetric warfare techniques, smaller forces leveraging advanced technology to challenge larger adversaries that we have seen in Israel war, Israel-Hamas war, and even in the Russia-Ukraine conflict, we are seeing interoperability and multi-domain operations, synchronization across land, sea, air, space, and cyberspace domains. So when we are using technology, it is providing us the interoperability and multi-domain operations capabilities, which are very, very important for the joint war fighting. So, as we have discussed earlier, that we need to integrate. When we are talking of joint war fighting, one of the key things is that integrating technology into our strategies of military operations. So key challenges in integrating new technologies into military operations. And the technical integration issues are legacy systems. We have so many legacy systems, and now the new systems are coming up. So how to make them compatible? Scalability and flexibility, how to scale in a multi-domain operation, and how at the same time we need to reliability and trustworthiness of AI algorithm is a big issue now. That how much trustworthy is our AI system? It's not only from the legal and ethical considerations, but if you think if the data is poisoned and the AI system some cues for decision making, and our leadership takes decision based on that on that cues which has been actually generated based on the poison data, and then the decision which is being taken. So how reliable and trustworthy it is? It can go against the user himself. So this is a very, very complex issue, that reliability and trustworthiness of AI algorithms. Then cyber security threats. Threats to critical infrastructure from cyber attacks. We have seen it in the recent wars. The attack on cyber physical systems by small UAVs attacking the refineries and making a very, very large impact with very, very small force structure, in fact, without using any forces remotely. Vulnerabilities to cyber attacks and adversarial manipulation. That is what I was talking while discussing reliability and trustworthiness also, that adversary can poison our data based on which our systems, if they are able to penetrate our network and poison the data, then the decision which will be taken on the basis of our AI and autonomous systems, and so that is prone to adversarial manipulation, and this is a key challenge in joint war fighting today, in today's scenario. Then high costs and resource constraints, R&D and implementation cost, that's a very, very high, and phased rollout. So when we are phasing doing the phased rollout, that also has its cost. And then ethical and legal implications, which is autonomous weapons making moral concerns. So these are the key challenges in integrating new technology into military operations. To move further, then there are ethical and legal concerns, use of AI-driven autonomous weapon systems, raising moral concerns. The black box nature of AI algorithms can undermine trust in automated decision, especially in life and death scenario. This is where I would like to mention that when you use the AI systems and autonomous systems as a black box, sometimes you should also spend time and task our scientific and academic community, and even in armed forces, we have very, very well-educated and highly qualified officers, that instead of black box, probably we should go deeper into it and try to understand the software, the decision-making algorithm which is inside there. And there comes also the evaluation of the systems. Sometimes we see that we trip that the evaluation of the systems which are using AI algorithms or information security related systems, the evaluation of that is taking time. But I'll tell you that it is very important to go inside it instead of treating it as a black box to see the algorithm, the software, we see the trapdoors, trojans, because it is a matter of life and death. We are talking of fighting wars. So the black box nature of AI algorithms can undermine trust, and that is very important, trustworthiness. And for that, we need to go a little deeper into the system instead of treating it as black box. Then over-reliance on AI systems could lead to strategic errors or unintended escalation of conflicts. This also is quite possible, and we need to be careful. Then multinational coordination issues, interoperability challenges. We have a lot of hardware which we have taken from various OEMs, not only from within the country. So the interoperability of the hardware and software which we are having already possessing, which have come from different sources, that is a multinational coordination issue. And the data sharing barriers, how to share data, how much to share data, what to share, what not to share. That is also a very, very key challenge. Then strategic risks are there, escalation risks are there. If we take a wrong decision by autonomous system, that can escalate a situation, unwarranted escalation. And there is a global competition. We see that global competition is there, say, we see between US and China. I will not take any names, but the global competition is a key challenge in integrating new technologies into military operations, because many times either we won't have the technology, access to technology, or it will be denied, or this global competition definitely affects the way we need to integrate the technology into military operations. Then what are the risks are there, but how to mitigate them? So that risks are there. What risk mitigation strategies we should adopt for mitigating the challenges in integrating new technologies into military operations, and develop modular architecture for the scalable system integration. It will be easy to evaluate also. I'm talking of security evaluation of when you have modular architecture, because the independent modules or various modules can be evaluated separately, independently. Enhance cybersecurity protocols through regular audits and advanced encryption techniques. Now we are coming to quantum cryptography also, but still it has not come into our day-to-day usage. Allocate defense budgets strategically for phased technology rollouts. That is very important. Invest in training programs to upskill personnel for new technological demands. Establish ethical frameworks for the responsible use of autonomous systems. And here it comes that the trustworthiness framework for trustworthiness, and then the laws for the what we say ethical usage of the autonomous systems. Then foster international collaboration to standardize interoperability protocols. So this is very important. And joint exercises are something which are really useful and really useful. So we should foster international collaboration to standardize interoperability, and maybe through joint exercise. So the first part of it, that joint warfare, what is the definition, the factors affecting it, how technology is more relevant, the key trends in technology, the risks in integrating technologies, and how to mitigate them. We have covered that. But having established that technology is a very relevant factor for the most important relevant factor for joint war fighting, the point is that how to use it. And there comes the second part of the presentation, and where I'll discuss that how to augment the joint war fighting capabilities through innovation and self-reliance. Lot of discussions, lot of committees, and the various revisions of defense procurement procedure, which is now defense acquisition procedure, review committees. Several things have happened. So I'll not go into details of this, but what I consider the national level challenges, I'll go to those factors and what are the key challenges without going into any particular organization or any particular service and all. Key challenges, in my opinion, when we are talking of technology and we want to use technology for augmenting the joint war fighting capabilities are. So with my experience and I have noted that these are three main things. One is the inability to attract and retain best talent. So one of the meetings recently, the counter question was that how much is the attrition in our scientific organizations or even organizations or the existing services. The point is not of attrition. The point is that what I mean here, that are we able to reduce the brain drain? If we see the list of CEOs in the USA, and you'll see that many of the CEOs of the leading companies, whom we can say that they were our best talents, so they are contributing for the companies abroad. We are not being able to reduce or stop the brain drain. And many of the research scientists, and to the point, to the extent that many of the IPRs which are generated by the multinational companies while having research establishment in India, not the intellectual property is in India, the rights are not here. So that is what I mean. When I mean it, I mean the brain drain part of it. That the talent which had not joined itself, not the attrition. So inability to attract and retain the best talent in the defense R&D plus production ecosystem. And when I mean defense R&D and production, I don't, my address is not limited to one particular organization, but I'm talking the national level, as a whole concept, that when we talk of defense R&D and production, are we able to challenge? And that we have to see that how to stop brain drain and how can we utilize brain drain for our defense R&D and production. Then procedural issues leading to time and cost overruns in the defense R&D, production and acquisition process. We are seeing that in defense R&D there are delays due to procedural issues. Many of the factors, one of the very important factors is the procedural issues. In production it is there. And when the systems are ready, then the acquisition itself is a very long drawn process. And when the systems were ready, we are trying to acquire the proven systems, even from the foreign OEMs. It took several years to acquire it. So that definitely affects our preparedness for joint warfighting. So the second point is procedural issue. The third thing which we should realize, that defense is a monosonic market. Monosonic market means, many of you know, but even at the cost of repetition, I'm mentioning it, that monosonic is the opposite of monopoly, and here monosonic means that there is a single buyer. So when there is a single buyer and somebody invests money, time, develops it, it goes under extensive trials, and if for any reason it is not procured, then it is not a viable business case. So how to address this? And sometimes when I point, the questions also come up that we can allow export. With my experience in dealing with industries and transfer of technologies, for the Indian industry, homegrown industry, if it tries to export, the first question the other country asks that whether your own armed forces are using it. If your own armed forces are using, then it is a testimony that it is a proven system and the others are also interested in procuring it. So in my mind, these are the three things in developing technology in this country which will be useful for joint war fighting. So let's see that why do we need to develop military technology in India? Now I'm talking of the self-reliance, innovation and self-reliance augmenting. So there is a triple trap syndrome, which says that what is developed abroad will not suit our threat specific requirements. What is suitable will be denied. We have seen technology denials in past and presenting also. I won't say that the threat is totally eliminated. And what is not denied will be unaffordable. It will be very, very costly. And we don't know whether every time we'll be able to afford it. And without a calculated degree of invulnerability to military technology denial, an independent foreign policy cannot be sustained. Self-reliance is immunity against technology denials. That is one simple definition by which I go. Is there any alternative to indigenous research and development? The answer is no. And some of the lessons to learn from UK. In 1991, the British Army, this is a case study, one publicly available, was interested in procurement of either MBT German, MBT Leopard 2, or USA made M1A2 Abrams. The British government took a decision for indigenous development by BDS, Vickers Defense Systems, and MBT Challenger 2 is a success story today, and it has been used in Gulf War. Then lessons to learn from Russia, Ukraine. Russia is able to sustain such a long war because of indigenous capabilities. And lessons to Israel-Hamas war. Again, we see that, I won't say indeed, all of us know that why indigenous research and development is important, and we can learn lessons from these wars. So the augmentation of joint warfighting capability is by augmenting the defense R&D plus production plus procurement ecosystem through innovation and self-reliance. We'll dwell further on this. This is my takeaway. How to develop it? We have seen that there are time and cost overruns. One particular solution which comes to my mind and which is a feasible solution is to promote technopreneurship. Entrepreneurship invites all kind of entrepreneurship. Technopreneur is technology based. Is a person who recognizes a commercial opportunity and pursues it through technology or intellectual property driven organization. I'll stop up to this part of the definition. So we should promote technopreneurship, and there is something called as theory of creative disruption. These are the people who have the capability to create something which will disrupt the existing system. And in the joint warfighting, military warfare, we need disruptive technology. We need disruptive technologies, and technopreneurs are the best way forward, which I can see that where we can go for it, and it will help us in developing technologies, indigenous technologies, which will help in augmenting the joint warfare capabilities. Today is the startup day, 16 January 2016 Startup India was initiated. So when we talk of technopreneurship, the flagship program of Government of India is the Startup India, and I put this definition of a startup only to so that not every new business entity is a startup. It has got a particular definition given by Department of Production and Industrial Trade. So this is entity is the definition says that entities should be working towards innovation, development, or improvement of products or processes or services. So when we're talking of innovation, we need to talk of startups. We cannot leave them. And when I talk of startup culture, so culture again I define as the way of life, and the startup culture, if we promote, it has got a lot of potential to develop technologies which will indigenous technologies which will help us, and we are seeing it in all fields, including chip manufacturing. Recently, we had a workshop on semiconductors and chip manufacturing, and we saw that some of the startups are coming in this area with very innovative solutions and developing the much needed critical materials indigenously in the country, based on which manufacturing chips can be manufactured. Even if we establish foundries, we need to reduce dependence on the materials, and there startups are coming. So, and the startups are the roots in the education system, and prior independence, the education system was not very conducive for startups. The startup culture began with opening of economy in 1991, and software companies were the first one to move. Today, we can claim that we have a startup culture because this data, which is few months old, it says that we have more than 1 lakh startups, and then 58,000 women-led startups are there. It has huge potential of employment generated, and many of them are in tier 2 and tier 3 cities, and we have more than 100 unicorns. So we can say that it has become a way of life, and we need to exploit it, rather use it for meeting the growth of augmenting our joint warfighting capabilities through innovation. life cycle I have just put up to show that there is a valley of death, and that is the place where most of the startups fail. And we need business models. And business model is defined as a business model describing the rationale of how an organization creates, delivers, and captures value. It is prudent to study the business models of tech startups prior to investment rather than after they fail. I put these slides intentionally, and we see their relevance in the next. So this is the way to analyze the performance of our startups. And there is lean startup business model, which again helps a startup to be successful. So here comes my intention behind putting those slides. The existing government programs to support innovation and entrepreneurship. You see, there are a lot of programs. Ministry of Commerce has Department for Promotion for Industry and International Trade. They have Startup India, then CTSS, Credit Guarantee Scheme for Startups. Ministry of Defense, we have TDA, IDEX. Ministry of Electronics and Information Technology also has program. These are another many programs are there. But why I have put these slides, I just wanted to show the point which I made, the second thing, the procedure. All of these schemes I analyzed and I found, you can also check, it is publicly available data, that the fund utilization, the funds are underutilized. So what is stopping us? And if the funds are not utilized properly or to the extent which has been already sanctioned, so we cannot say that funds are not available or government is not supporting. Somewhere some procedures are stopping us and the funds are not utilized. How can we be sure that our startups and technopreneurs will be able to develop and deliver what the technologies and the systems we want from them? So procedural issues are one area where we need to look at if we want the technologies to be developed at a faster rate for meeting the requirements of armed forces. These are a few more techniques. Then in Startup India, how it is being used in IDEX, TDF, Technology Development Fund. So there comes one more issue, one point which comes. I'm going to now to the root when we want to augment our technological capabilities. So technopreneurs is one solution because it takes care of two things. One is best talents. Most of the startups have been started by the best talents who have opted to remain in this country and develop technologies and make this country self-reliant in addition to their business goals. It also takes the care of the procedural issues because they have the linear system where technologies can be developed faster. But at the root of all this is the role of academic institutions. And if we see the leading universities in Silicon Valley, University of California at Berkeley, Stanford, and UC San Francisco have served the evolution of Silicon Valley. And they have adopted the following approach. It says that fostering entrepreneurship education through the creation of new programs, competition, and activities even in the non-entrepreneurial courses and in multidisciplinary contexts. Commercialization of science and technology through entrepreneurs. Connecting universities and their communities, staff, students, and alumni. Creating advanced infrastructures for translational research that may be expected to become ever more closely linked to incubation and accelerator programs. So there is a role of university system, the academic institutions in promoting entrepreneurship, technopreneurship, which in turn will, and if you see the many of the defense technologies which have come up in the USA, in Silicon Valley, which have come out of the universities. If you see the Stanford's website, the technologies are mentioned. If you see the DARPA website, you can see that how many have been developed from the academic institutions, including internet. And in the Indian scenario, the startups are crucial to economy because they create jobs which lead to lower employment rate, which in turn signify more developed economy. More than 1 lakh TPIT recognized startups. The institutions which have played vital roles are IITs, followed by IIMs, ISB, and Spillani. IIT Madras has set up center to study Indian startup ecosystem, and India has many well-known startups. So the question is that how Stanford, UC Berkeley, and UC San Francisco universities are helped. Can we do it in India also? The answer is yes, and these are the 4 points which we can do. So coming back to our original theme, that how technology is relevant and what is the future outlook for that. So emerging technologies on the horizon, as I was earlier mentioning, the quantum computing for faster decision making, hypersonic defense systems, they are the two technologies which are yet to be inducted or be used in day-to-day operations of military. So these are the two emerging technologies which I have put on slides. Then advanced Internet of Military Thing applications with 6G networks for real-time battlefield monitoring. This is also emerging area which is yet to be fully exploited. Then the recommendations for a smooth technology absorption. We need to collaborate between government policymakers. I'm including all public funded R&D institutions, industry, academia. I put some slides for academia deliberately because they have got a very, very major role to play in technology development. And not only technology development, but also academia are the institutions which not do only research, but they also develop the manpower, the technopreneurs or startups, the founders who will run those institutions tomorrow for developing the technologies. So we need the collaboration between government policymakers, public funded R&D institutions, industry, academia, and the armed forces, who are also the users for innovation scaling. Then training programs for military personnel to adapt to new tools, and balancing tradition and innovation. Traditionally, we have a doctrine, we have a strategy. We need to integrate technological advancements without undermining conventional methods. It's not that conventional methods will not remain relevant immediately. So until unless we integrate it, balance it, and then practice it for a certain period of time, then we'll be able to say that this doctrine itself is a new doctrine. Conclusion. So some of the key points that technology is a force multiplier in joint warfighting. This is one of the concluding points. And the need to address challenges while embracing innovation. We need to address challenges of developing technologies and augmenting the joint warfighting capabilities while embracing innovation and self-reliance. The conclusion is that improve procedures along with their implementation to promote efficiency and deliverability. Deliverability is very, very important because we have seen the time and cost overruns in the projects, not only in the development projects, but also in acquisition from foreign OEMs. And also when we have developed the schemes like TDF and IDEX, there also funds are underutilized. So we need to improve our procedures and promote technopreneurship leading to innovation and self-reliance. If we promote technopreneurship, it has the potential for create destruction. That is the Schumpeter's theory. And that is what we need to disrupt the technological era and go to technologies which will give technological advantage, unfair technological advantage over the adversaries. And this is my last technological slide, and this is my wish list, that we are talking of Aatmanirbhar Bharat. Why don't we talk of Sarv Pratham Bharat? Can't we become the first in the world? So this is my talk. And let us make our country technologically more advanced, economically wealthier, and militarily stronger. That is my wish list. I'll come to the end. This is my contact details. Jai Hind.